So several months ago, there was a problem that was on the internet that confused a lot of people, and people started taking sides. And no, I'm not talking about this one, although that was also quite a controversy. I'm talking about this math problem here. And people took sides because they were so sure and so convinced that they had the right answer, and therefore the other side had to be dumb. And because I teach PEMDAS to my physics students, it only makes sense that I make another one of these videos to add to the 5 million or so that are already out there on this topic to explain it. Now, on one hand, I'm super happy that people are taking an interest in math. But then on the other hand, this is what I saw in the comment sections of all of these videos. Now, if you want to see the proofs of each answer, there are many videos. However, this is the only one you're really going to need. The truth is, the squabbling is all nonsense. Now, I'm going to make a reference here to the movie The Matrix. So if you saw the movie, you would recognize this scene. This is Morpheus with the red pill and the blue pill. And if you choose one, you get the answer 9. If you choose the other one, you get the answer 1. You can read the stuff that's on the slide by pausing it if you want, but I'm not going to delve into it too deeply here. Morpheus asks in the movie, what is real? And you should totally look up that clip if you've never seen it. I put the transcript down in purple down at the bottom of the slide. But the bottom line is, you can believe whatever it is you want, but mathematically speaking, which follows a certain set of rules like the matrix, there is only one answer. And so the answer reminds me of a question posed to deep thought. Okay, I'm done teasing. The answer to the problem is unequivocally 9. And yes, 9 is correct, because our tools are governed by the matrix. Well, sort of. And language barriers have always caused problems, and yet the language of math is unambiguous, and it is logical as long as it is properly applied. Compare this to English, which can be ambiguous. And here's an example. I saw a man on a hill with a telescope. Well, that could mean that I saw a man who was on a hill holding a telescope, or while I was looking through a telescope, I saw a man on a hill. So math follows certain rules, but even more importantly, calculators are governed by a set of computational rules as well. So if you intend on using a calculator, you need to understand how it processes your input. A calculator is simply a tool that makes your computations easier by following a preset series of rules, which are orders of operations. So in other words, your calculator, or Google for that matter, follows PEMDAS explicitly. We trust our computers to get the correct answer, and thus GIGO, which stands for garbage in, garbage out. Faulty user error in your inputs will lead to faulty answers. So computers follow rules, and that rule is PEMDAS. Now, people made computers, people made math symbols. They also came up with the meaning and application of those math symbols, and PEMDAS was a standardized rule set built around those symbols and their respective applications so that one could distinguish between the ambiguity of something like 6 divided by 2x. Now, per PEMDAS rules, 6 divided by 2x can only be viewed one way, but remember, garbage in, garbage out. So prior to electronic word processors and equation editors, it was really inconvenient to try to write things in a book in fractional notation, and so printers started using the slash. However, the slash required parentheses so that we understood what was in the numerator and what was in the denominator. And thus, 6 divided by, or 6 slash parentheses 2x, is distinctly different than 6 slash 2 times x. Therein lies the unequivocal nature to the answer. As written, 6 divided by 2 times the quantity of 1 plus 2 can only equal 9. Now, to those who argue that the distributive property of multiplication implies that 6 divided by the 2 times the quantity of 1 plus 2 is actually 6 divided by the quantity of 2 times the quantity of 1 plus 2, I say this: you are lazy and you are wrong. If 6 divided by 2 times the quantity of 1 plus 2 actually meant 6 divided by the quantity of 2 times the quantity of 1 plus 2, it would be written as such, which makes you lazy. As written, it has only one explicit answer. That is the beauty of math as a language. Okay, so you're still unconvinced and you think I'm a pedantic blowhard. Fine. So let's look at this problem here. Now, first thing, almost everyone should agree that you do what's in the parentheses first, and that leaves us with 6 divided by 2 times 3, right? So for those of you who ride the distributive property of multiplication train, I am now going to submit to you the associative property of multiplication. 6 divided by 2 times 3 is the same as 6 times 3 divided by 2 is also the same as 1/2 times 3 times 6. If you are unconvinced, multiply all of these out and you will get 9 for all of them. You see, there's a reason that computers will always say that the answer is 9, and this is why. You see, per the associative property of multiplication, you could also look at 6 divided by 2 times the quantity of 1 plus 2 as equivalent to the quantity of 6 divided by 2 times the quantity of 1 plus 2, because 6, 1/2, and 1 plus 2 are all factors in the expression. The distributive property of multiplication. The overused erroneous argument is thus: 6 divided by 2 times the quantity of 1 plus 2 is the same as 6 divided by the quantity of 2 times 1 plus 2 times 2. You might think that's true. It is not. So to see the error of their ways, let's pretend that instead of dividing, we multiply. So instead of 6 divided by 2 times the quantity of 1 plus 2, let's say 6 times 2 times the quantity of 1 plus 2. And for those of you who missed my video on why PEMDAS could be shortened to PEMA or PEDS, you would be wise to learn that multiplication and division are simply inverse operations of the exact same thing. So this is easy. Everyone should get 36 for an answer. There is no ambiguity here, and yet the same associative property of multiplication is at play. These are all forms of the same thing. So why all the problems when dividing? What is it that's so magical about division that causes folks to mess up and fault the distributive property for their error? Well, the answer is something I alluded to in a previous slide, and that divided by 2 is actually the factor 1/2. So you see, 6 divided by 2 times the quantity of 1 plus 2 is really the same thing as 6 times 1/2 times the quantity of 1 plus 2. Indeed, you should see there is far less ambiguity now, because 6 times 1/2 times the quantity of 1 plus 2 equals 9. Okay, so you're still not going to let this distributive property thing die, will you? So, okay, let's look at the distributive property. 6 times 1/2 times the quantity of 1 plus 2 equals 6 times the quantity of 1/2 times 1 plus 1/2 times 2, which therefore equals 6 times the quantity of 1/2 plus 1, which equals 6 times 1.5, which lo and behold equals 9. So there, once again proven with the distributive property, only this time correctly applied. So in summary, 9 is the one and only correct answer to the problem 6 divided by 2 times the quantity of 1 plus 2, as written. What you believe is your own business. But the reason calculators and computers will agree that 6 divided by 2 times the quantity of 1 plus 2 equals 9 is because people designed them to compute per our rules, which are not arbitrary. And finally, dividing by 2 is the same thing as multiplying by 1/2, and therefore if you really want the expression to equal 1, then use parentheses appropriately and write 6 divided by the quantity of 2 times the quantity of 1 plus 2. Thank you for watching.